Okay, let's go over. So we have some new apps. So yesterday we published 4. It's this circular motion illusion. I don't know if you've seen it already or not. Go check it out. I'll pop the link in the chat again for your convenience, just also for me to know we actually covered this one already, so I don't talk about it again. So yes, those circles move in straight lines. There's no circular motion whatsoever. But without the helper lines, it does look like they're moving in circular motion. They are not. Well, they're kind of in relation to one another, but there's nothing circular going on the screen. So therefore, the illusion. Let me know if you wanted to talk more about it. Yeah, we covered the brain recording modalities. The link is in the chat. What else we've published? We published this Eigenfaces. I won't be showing it again. I probably can. So you turn your camera, you capture your face. You do something with your face, like opening your mouth. And then you can actually automate the thing. It will animate your face. We don't need the camera anymore. Just close the camera, and from the eigenvectors we have your face animation. It's a bit low res, don't know why. Let me know if you tried it out. This one's called PCA because yes, it does rely on principal component analysis to calculate the eigenvalues. So we published that one yesterday. Go check it out. I have this MRI Synthetic Brain Simulator. It's working mostly on desktop because you kind of need the mouse for it. It doesn't on the touchscreen. There's no separate controller for scrolling through the slices. And as you can show some pathology in the brain. This is of course synthetic brain generator. Can change your view. This is obviously not quite accurate, especially because the resolution is medium. You can have a low resolution, it will be even worse. But yeah, with the very high resolution, it's actually quite heavy on the browser. So currently we also recording this video and streaming, so we won't be going very high. But yeah, go check this out. The demo mode meant to actually do something useful as well. It is not at the moment. Let's see how we fix it later on. So we got this synthetic MRI. I'll share the link quickly so you can go check it out and provide your feedback. We also had this interactive MRI simulator. So it will show you how the MRI actually works, if you were wondering. Yeah, don't ask your lecturer, they would either not know or will have trouble actually explaining it properly. You really need a simulation to understand that kind of stuff. So there is one for you. To try out. It's automatically when you're loading page, it will go, if you're not interacting with the page, it will go into demo mode. The sound will be on. For you to actually hear the sound, you do need to interact with the page, so you'll have to click somewhere on the screen for the sound to work. And then we'll randomly set parameters, the magnetic field strength and the degree, the pulse, RF pulse intensity, which will determine the degree of the spin. Yeah, and then generate 10, obviously, synthetic slices. So you can see how MRI machine works. Oh, we had some more illusions. Yeah, they are ready to go as well. I mean, they are published. You can go check them out on this link. I'll pop it in the chat. There should be a demo that actually works. This one should be good for... let's try the thinking model. Gemini 2.5 Flash thinking. We'll try it as a prompt engineer. Can you have a look what's currently on the screen? We are live streaming at the moment, so you can address the viewers directly rhetorical questions, encourage them to go visit the website. This simulation web application is published on this address, so that the viewers can go check it out. So if you can address the viewer directly and describe what you are looking at in the screen, make it engaging and fun.
Check out this incredible optical illusion on the screen right now. Do those two red lines appear to be misaligned, even though they should form a single straight line? That's the famous Poggendorff illusion, playing tricks on our minds. You're watching an interactive viewer that lets you see various illusions. If you want to experience these fascinating illusions for yourself and play with the settings, head over to bionichaos.com/illusion. It's super fun, and see how your brain perceives things differently.
Okay, can you actually explain this illusion some more? What's happening when I change the parameters? What's going on, and how does it change the strength of the effect?
The Poggendorff illusion is a fascinating example of how our brains can be tricked. Essentially, the intersecting lines cause the two segments of the straight line to appear misaligned, even though they are continuous. When you adjust the bar width slider, you're changing the size of the obstruction, which can influence how noticeable the misalignment appears. Similarly, changing the line angle affects the perceived relationship between the segments, sometimes making the illusion stronger or weaker, depending on the angle. It's a fascinating way to see how our brains construct our perception of reality.
So I missed the main point. What's the actual illusion is? Can you explain looking at the screen? I think now it's the strongest as well with this settings.
The illusion you're seeing is the Poggendorff illusion. Notice the diagonal line that passes behind the gray rectangle? Even though it's a single straight line, the parts of the line on opposite sides of the rectangle appear to be misaligned or shifted. It's a great example of how our perception of lines and angles can be influenced by surrounding elements. Try adjusting the sliders for bar width and line angle to see how the illusion changes. You can check this out yourselves on bionichaos.com/illusion.
Okay, and what's happening when I click the reality check button?
When you click the reality check button, it typically reveals the true alignment of the lines, showing that the illusion is just a visual trick. In the case of the Poggendorff illusion, it would likely show that the two segments of the diagonal line are actually perfectly aligned and form a single straight line behind the rectangle, confirming that
Can you actually look at the screen and confirm what exactly happens when I hit the reality check button? Can you explain what's going on?
Okay, looking at the screen now, when you press the reality check button for the Poggendorff illusion, it reveals the true alignment of the lines. You'll see that the two segments of the diagonal line are actually part of a single straight line that continues perfectly behind the gray rectangle. This demonstrates that the perceived misalignment was just an optical illusion.
That's why I was actually trying to confirm with the mouse pointer, not realizing that it's not a straight line. It's not a straight line. Yeah, the side of it, but yeah. So how do we know what's the strongest? What's the settings that make the illusion stronger? Can you have a look and tell me what you see? When does the illusion become stronger? With what settings?
Based on what's shown on the screen, the illusion tends to appear stronger when the bar width is increased, meaning the gray rectangle is wider. Also, certain angle settings seem to enhance the misalignment perception more than others, particularly when the lines are at a moderate angle relative to the bar. Experimenting with the sliders allows you to find the specific parameters that create the strongest illusion for your perception.
Okay, that's fine. I don't know if you can... Oh, you can't actually see the drop down. Well, in this case, drop up, whatever. But yeah, if we can look at the other illusions, so you can explain this one, what's going on, when's the illusion effect is the strongest.
This is the Kanizsa triangle illusion. It's strongest when the cutout sections of the black circles align perfectly to suggest a distinct white triangle in the center, even though it's not directly drawn. Adjusting the mouth slider to control the size of those cutouts and the angle slider to align the shapes properly will make the perceived triangle appear most clearly.
Yeah, but can you talk specifically about, like, when, how does what we see prior is actually affecting the strength of the perceived illusion? Like, so can you try and explain that?
What you've seen previously can definitely influence how strong the current illusion appears. It sets a context for your visual perception. For example, after viewing the Poggendorff illusion, your brain might be more tuned to detecting misalignments or disruptions in lines, potentially making the next illusion seem stronger. Each illusion primes your brain's processing, creating a context that affects the perception of subsequent visual cues.
Okay, can you just summarize this one? What's happening when we change the number of rays and the convergence lines? I think the convergence lines actually meant to do something else. They're meant to be splitting up and down in addition to left and right. Anyhow, and explain the reality check. What's going on?
In the herring illusion, you see two parallel horizontal lines overlaid on a background of radial lines that converge towards a central point. When you change the num ray slider, increasing the number of rays often makes the illusion stronger, making the parallel lines appear more curved. Adjusting the convergence setting changes where those radial lines meet, affecting the perspective cues and thus the degree of perceived curvature. The reality check button typically removes the radial lines, showing only the two parallel lines, so you can see they are indeed straight, confirming the illusion's effect. Hey everyone, you're looking at the Müller-Lyer illusion now. Pretty cool, right? It looks like the two horizontal lines are different lengths, but they're actually the same. You can experiment with the sliders on the right. Try changing the wing length and wing ankle sliders to see how that affects how strong the illusion looks. And if you want to see the reality, just click the reality check button. It'll show you that the lines are indeed the same length. Give it a shot and let us know what you think. The links to this interactive illusion viewer are right in the chat or description below. Wow, check out the Ebbinghaus illusion. Isn't it amazing how the central red circles seem to change size just because of the circles around them? On the left, surrounded by larger circles, it looks smaller, while on the right, next to smaller circles, it appears larger. When you hit that reality check button, it clears the surrounding circles, instantly showing you that they are the exact same size. Isn't that wild? It demonstrates how our brains use context to interpret size, which is a fascinating part of neuroscience research. Our perception isn't just about direct measurement, it's about how our brains interpret information based on the surroundings. So cool, huh? These optical illusions are mind-bending. You just saw the Müller-Lyer illusion, where lines seem different lengths just because of the arrows. Then there was the Ebbinghaus illusion, showing how a circle size appears to change depending on the circles around it. Both play tricks on our perception, highlighting how our brains interpret context. You can try all these interactive illusions yourselves, using the link in the chat or description. Dive in and see how your perception gets deceived. Aha! Isn't this stuff just fascinating? It really makes you wonder how much of what we see is just our brain playing tricks on us, right? These illusions are perfect examples of how our visual perception can be deceived. It's a real workout for your brain. Don't worry, your brain isn't broken. It's just trying to make sense of things in its own unique way. Seriously, you've got to check out the rest of these illusions on the website. The link is right in the description or chat. Prepare to have your mind truly deceived. Isn't this amazing how easily our brains can be fooled? These illusions are a fantastic way to see our perceptual systems in action. They show us that our reality is often constructed by our brains, not just a direct reflection of the world. This understanding is super important in neuroscience, helping us map the complex pathways involved in vision and how we perceive the environment. And guess what? It's also crucial for biomedical engineering and data science. Designing effective medical imaging systems or visualizations for complex data requires understanding how humans perceive visual information, including these potential biases. So, next time you see an illusion, remember it's not just a trick. It's a window into how complex our own perception really is. Don't forget to check out the rest of the illusions on the website via the link. So, what are your burning questions about these amazing illusions? Whether it's about how they trick your brain or how this relates to things like biomedical engineering or neuroscience, fire away. Or maybe you're wondering how understanding these illusions can help us design better technology or understand the brain better. Don't hesitate to ask. This interactive experience is all about exploring the fascinating ways our brains work. And don't forget to check out the rest of the illusions on the website. That's a fantastic question. Psychophysiology, which looks at the connection between psychological states and physiological processes, finds optical illusions incredibly insightful. When you perceive an illusion, your brain is actively working to interpret the visual information, and this process triggers physiological changes. Think about eye movements, brain activity measured by EEG or fMRI, or even subtle changes in your heart rate. All of these are ways psychophysiology explores how our minds interpret the world visually. It's a direct connection between our perception and our body's responses. Isn't that fascinating? It really shows how interconnected our mental and physical selves are. Be sure to keep exploring these illusions on the website because each one offers a unique window into how our brains construct reality. Optical illusions are essentially our brains trying to make sense of visual information, and sometimes they take shortcuts that lead to perceptual errors. We can actually increase the effect of many illusions.
Okay, I have trouble with this model. Well, mainly because it's already having, so this is Gemini 2.5 Flash Exp native audio thinking dialogue. So it's actually giving better responses, much better than one of the other models available, but it gets, the tab in the browser is currently 4.2 gigabytes. It's like, what? Why? I think it's storing all the screen recordings within the tab, which is weird. To limit its context size or something. But there's no options like that. Anyhow, yes, so yeah, we popped the links to the website. So everything we do on BioniChaos is available on BioniChaos.com. Go check it out. Don't forget to provide your feedback. Obviously, optical illusions are highly relevant to biomedical data science, don't they? Don't they? Don't they? Don't they? Yes, we covered the different brain recording modalities, comparing temporal resolution, spatial resolution, which is like the quality of the signal relevant to signal to noise ratio, cost, portability. We had another illusion there, again, highly interactive. Yeah, that's interesting because many people don't actually see the illusion. So obviously with one dot you see it's moving left to right, that's kind of a no-brainer. But then with two dots, after I showed you the one dot, well, for me, I don't see the illusion. So I see the two dots moving in lines. I don't see them circling. Once I go three dots, to me it's an obvious circling, even though there's no circling going on. They're just going up and down those three lines. Interesting enough, I think this is where the threshold is. Some people, I think there will be like a 50-50 split. Some people will see circle motion and some, like myself, will not. And then it becomes stronger and stronger with 4 or 5 whatever lines. You do definitely see a circular motion. And again, there isn't any. all the dots, you can follow each dot. This one, for example, is going up this line, then goes back down again, the same line. So no circles, nothing is moving the circle. Well, the only thing that is moving the circle is if you show this helper, which actually shows you additional line which wasn't there before. So that's the only circle thing, even though, yeah, when you look at it without the lines or the helper, yeah, well, you get the drift. So yeah, and you can try it out yourself on BioniChaos.com/circmotion. So I have eigenvalues recorded. We took, I think it's 3. Actually needed 3 images to get 2 Eigenfaces. And now we're able to do this demo where we just animate our face. We don't need to turn our camera on anymore. We can just talk, and well, this one's just going, the weights for the 2 eigenvalues are just going up and down. That's what's animating my face, but I can tie it. One of the weights, or 2 weights for mouth open, mouth closed, whatever, Eigenfaces, can tie it to the amplitude of my voice, and then we'll just move my mouth open and close. We had a synthetic brain generator, which you can go check out. Select your resolution, the type of view, axial, coronal, sagittal. Show healthy brain or a pathological one. This one has something in it. Something in it that you probably better go check out. We had this interactive MRI simulation. So we had a bunch of them before. Well, I mean, we had this synthetic one and a bunch of these kind of things that show you the inside, what's happening inside the MRI machine, you know, with the proton spin and stuff. So in this case, you can choose your magnetic field strength and the pulse degree of rotation, so intensity of rotation. Stop the demo for a sec. Can just do it manually. So with this high spin, the electrons go all the way to 90 degrees, 18 degrees. They just do a tiny angle there. The strength of the MRI going all the way from 0.5, so this will move slowly all the way up to 3 Tesla. You're probably asking why it doesn't go up to like 12 Tesla. The answer is at the bottom of the page. Well, essentially just because we actually were thinking about it, but then it's not clear how would the simulation actually change to, yes, if you have 3 Tesla, if you have more Tesla, does it mean your resolution of the image goes higher? Probably. Should we bring a prompt engineer on that? An expert. Anyhow, so you can go check out this tool yourself, provide your feedback. And the illusions, obviously illusions are highly relevant to, well, particularly behavioral neuroscience. So let us know if you have any questions about any of the tools. We have more coming. All of them are on BioniChaos.com. Go check it out, provide your feedback. Your feedback probably would not change the current simulation, would probably start a new one. Just because the first engineering rule is, if it's ain't broken, don't touch it. But then we'll just, based on your feedback, we'll actually develop a new web app. So let us know what you think. And if you tried any of the tools, even better if you could record like a video of you using one of those, that would be awesome. You can start your own YouTube channel. The other thing with optical illusions is that whatever I showed you prior affects. So if I showed you 3 dots first, which to me appear like they're moving in a circle, and then I look at the 2 dots, it does to me look like they're still moving in a circle. So if I move from 3 to 2, they look like they move in a circle. But if I go 1, which obviously, I mean, surely everyone will see it just moving in a straight line. If I show you 1 dot first, and then I show you 2 dots, well, now it's kind of 50-50, but yeah, but it's, I can still, to me it seems like they're moving in straight lines, which they obviously do. But yeah, if I move from 3 to 2, then the effect is stronger. So in behavioral neuroscience, whatever I showed you prior affects your current perception. So that's what they do in the restaurant menu, whatever, when they show you prices. They, what's called, prime your decision by showing you things that they know you're not going to order because it's too expensive, but they set, your perception of the second most expensive item to be less expensive. So that's what's happening here. And you can go check it out yourself, play with it, maybe record a video of what you see and when does the illusion, most prominent for you. Okay, and also obviously let me know if you wanted to talk about any of the other tools on the website as well. Obviously simple magnets are relevant to MRI today. I don't know. The simple magnets relevant to how MRI works. Or not really. Probably not really. Should we do a simulation of an electromagnet? Maybe next time. And obviously we have a Fourier transform visualization as well. We have a couple. This one you can actually interact with. Yeah, so you can actually do a drawing. It will find the center of mass and will apply 10 vectors to try and replicate your drawing. So you can actually zoom and see the 10 vectors working hard. Obviously, if you have just one, it will be just a circle around the center. If you have two, it will do a very lousy job. Well, just an ellipse. So is that the difference between a circle and an elliptic shape? Each one you have one vector. For an elliptic shape you need 2 vectors. Okay, what happens with 3? So you have this like a bean-like, a brain-like shape. 5, yeah, more of a bean. 7. So it's trying to calculate the vector, the length of each vector to replicate your drawing. So if you do something simple like a love heart, it will actually be able to do it in a kind of artistic fashion, which is nice. You can have a look at the 1, 2, 3, 7 vectors at the moment, and able to replicate this simple drawing. Oops. But if you try something more complicated, they will obviously struggle, so you'll require more vectors. Let's go to say 13. It's doing better. 21. Yeah. So guess what this is? Go smash that like button. Do we need 4 fingers? Is this any better? Yeah, and it's able to turn it into this artistic thing. Taking a simple drawing, making something more interesting out of it. And you can actually zoom and follow along, see what exactly it does. Okay, so yeah, let me know if any questions, if you have any ideas for a web application to go on to be part of the BioniChaos.com collection. Also do let know, and I'll see you next time. Yeah, we have another Fourier simulator, which is based on the, I always forget, is it 1 blue, 3 brown, or 3 brown, 1 blue, whichever way it is. Made a video on this 7 years ago. So this was done in JavaScript. All the code is just available for you on the page. JavaScript within HTML. There should be no external libraries except the plotting ones. So it will be like the 3JS or something similar. And you can actually play with the simulation yourself.